Mr. B presents the number I. Okay, first off, there are 4 different types of problems we're doing with the number I. And if you remember from class, I equals the square root of -1. That is the whole idea behind I, meaning that I squared equals -1. The 4 different types of problems that you're going to see on the final are addition, subtraction, and multiplication in a couple different ways, but we're going to tackle that in 2 parts, so it's technically 4. All right, let's start with addition. All right, so we've got our problem, 3 plus I plus the quantity 4 plus 3I. Now what this boils down to, more or less, is that we're looking for like terms. So we see this is a number, this is a number, so we can go ahead and add those numbers. I have 3 plus 4, we get 7. And then the separate set of like terms is I and 3I, right? So when I add 1I plus 3I, I end up with, drum roll please, 4I. Boom, problem done. The best way to deal with i's, especially when we're doing these addition, subtraction, multiplication problems, treat it like x. When you add x's together, you get more x's. When you subtract them, it's the same. 3x minus 2x would be 1x. And when you multiply them, you end up with a x squared. In this case, instead of x, we're just saying I. And while I squared has a special property, we can still treat it and get so close to the answer, treating it just like x. So all I did was I took my like term, 3 and 4, and I added it to glorious number 7. Then I said, I plus 3I is 4I. Looking good. The way I like to read subtraction problems is I almost do it sort of like a Disney sing-along, right? So I start with my like terms. I know that 5 and 2 are going to be like terms. And then what I mean by Disney sing-along is I read it out loud in my head and I make sure that this subtraction symbol makes it into the lyrics, okay? So I go 5 minus 2. 5 minus a positive 2. We all know that 5 minus 2 is going to give us a trace. And then samesies with the i's. I know that 5i and 2i are like terms, so I'm going to, once again, read it out loud. 5i minus positive 2i. 5i minus positive 2i. And I get 5 minus positive 2, and it's going to be positive 3i. Boom! Just like we would do with x, as I keep saying. Let's move on to the multiplication. Okay, so now we're basically just distributing this 4i right here to both the 2 and the 6i, just like if we had x times the quantity 2 plus 6x, just like if we had 4 times the quantity 2 plus 6x, anything like that. It's all the same. So, just like we always do with distribution, I'm going to make sure that my lines are up here. They're going to remind me that I'm going to do it to both. So let's give it a go. I get 4i times 2, which equals 8i. And then I get 4i times 6i. This gets a little more complicated, but not by much. 4 times 6 is going to be positive 24. And I times I, just like when we're dealing with x's, is going to be I squared. Now, at the beginning of this video, I reminded you that I squared equals -1. That's its special, unique property. So what I really get is positive 24 times I squared's secret identity of -1, which equals -24. So my final answer is going to be 8i minus 24. For your final answer, you should have no I squareds. If you have an I squared, then you haven't converted it to its secret identity, -1, and therefore cannot get full credit. And you know this. So my rule of thumb, if I have something I squared, like positive 24 I squared, I just go ahead and flip this sign. So I had positive 24 I squared, and what I'm going to do is I'm going to scribble out this plus sign, and I'm going to say, no, I know I squared is -1, so it's going to turn this 24 to negative, and that I squared is also going to get scribbled out because it goes away. And what I'm left with is -24. Let's do one more multiplication. Once again, we find ourselves just distributing these guys, and we're going to use our tried and our true, poorly named rainbow butt crack. We've been doing this all semester. I know you can. So let's just hit it off. I get 2 times 2i, so I'm going to get 2 times 2 is 4, and we can't forget that I. I'm going to do I times 3, well, just like treating it like an x, I'm going to get 3i. Now to the butt crack part. 2 times 3. I think that's 6, but we'll never know. And then I times 2i. So we're basically saying 1i times 2i. I'm going to get 1 times 2 is positive 2. And then I times I is I squared, which we know the secrets of. But now let's combine like terms. 6, 2i squared, not like terms yet. But first off, I know we have 4i plus 3i. We can add those up and get 7i. Now, the secret of the elusive I squared, I know that this I squared secret identity is -1, and therefore this positive sign is going to turn to a negative, and then I'm going to scribble this out. So I get, realistically, 6 minus 2 for a final answer of positive 4. Boom, we did it. I'm very proud of you.